All right. Hello, everybody.
Hi, everyone. Welcome to Dome to Home. Thanks for joining us again this week. My name is Tara. I'm a planetary scientist and a CU alum, and I'm also a presenter here at Fiske. And I have Miss Amanda here with me. She's going to be our navigator today. Hi, Amanda.
Hey, how are you guys? I was here last week, and I'm excited to keep going with our theme of Mars and learn a bit about the planet itself today.
Yeah. So everything that you see on the dome right over here, Amanda's going to be doing all of that live. So she's going to be flying us around, and we're going to be looking at Mars and seeing some different pictures, and it's going to be a whole lot of fun. Now, we also have our friend Rainey here. She's monitoring our chat window. So if at any point you have any questions, go ahead and throw those in the chat. Rainey will keep track of those. I'm going to try to answer some as we go, but we also have time at the end that'll be dedicated just for those questions too. So also, if you get to any point and things are kind of hard for you to see on the screen, try making it full screen on your computer. Sometimes that makes it a little bit easier to see. All right, I think that's all the introduction stuff that we had to go through. So, yes, thanks again for joining us today. We are still on our theme of Perseverance to Mars, talking about our spacecraft that's headed to Mars. It's going to land on the planet and rove around and hopefully teach us some really cool things. And so we're kind of exploring stuff about Mars while we're waiting for Perseverance to get there. And today in particular, we're going to be talking about how Mars, the planet, formed and what sort of evolution it's gone through over the last, like 4 billion years or so since we think that it came around. So to talk about how the planet actually formed, we actually have to start with how stars form, because those two processes are linked together. So stars, you know what a star is, yeah? Stars are born in these huge clouds of gas and dust, like this one that you see here on the screen that Amanda just put up. This one's called the Crab Nebula. Nebula is just another word for cloud, so we use that word a lot. Now, these nebulas are actually the remains of old stars that died. Really big stars, when they die, they basically explode. And they shoot all this material out into space, everything that was inside or around the star when it blew up. So these pretty clouds and all these nice pictures that you see, these are all star guts. It's pretty cool. So you have all of this material that's out in space in these big, pretty clouds. There's lots of different elements and atoms and stuff like that, all floating around in space. But as these clouds, they're sitting out there, and like you can see in the picture here, some areas have more stuff in them than others. There's more of certain gases in one spot or another spot. Now, these areas that are denser with more stuff in them have more gravity. And so they'll be able to actually pull in more stuff. And so these thick clouds get thicker and thicker and thicker, and then they get bigger and bigger. And as they get bigger, they get more gravity, and it starts to be kind of a runaway thing there. And eventually they'll get so thick and so dense that they'll collapse and form a star, which is super cool. So the stars that we see are born from the guts of the old dead stars. Now, they don't bring in all of that gas and dust and material with them. The star will form, and there'll still be some leftover stuff kind of orbiting around it. Now, some of that stuff will start to form its own little clumps. And these clumps will start to orbit around that star because the star is so much bigger. It's got so much mass. So what you see here, these pictures, these are from a telescope called ALMA. And ALMA is looking out at stars that are just being born. So these are all very, very young stars, and they still have those clouds of gas and dust kind of around them. But you can see how there's kind of dark little circles around there. Those are the paths of these little, what we call protoplanets. These are little baby planets. There's little clumps of rock and dust that have smushed together, and they're orbiting around that star. And as they go around, they're kind of scooping up more gas and dust from these clouds as they're going around. So that's what the dark areas that you see are. And that's how we think that our solar system was born. All of these little protoplanets were all mushed together, and they started orbiting around and scooping up more gas and dust and getting bigger and bigger until they made the planets that we have today. And Mars is no exception. Mars is a pretty small planet, but it's a planet nonetheless. And that's pretty much how it formed. Now, one of the important things that exists in these clouds of gas and dusts and elements and stuff, they're really rich in the element hydrogen and the element oxygen. And if we smush hydrogen and oxygen together, what do we get? We get water. 2 hydrogens, 1 oxygen, H2O. So this is one of the ways that a planet gets water, is it comes out of that cloud. These elements are incorporated into that planet as it's being born from all of that gas and dust and stuff. And so these atoms will smush together and make water. And so that's probably we think the main way that planets get to have water on them. So this is a really important thing to think about when we're thinking about places that we might want to live, like Earth or Mars. I see Jeremy has a question here. How big are these clouds? These clouds of gas and dust that make stars are huge, like millions of light years across. They're massive, massive, massive things. These are very, very large. So you can see in the picture we have here, this is here's the Crab Nebula here. There are tons and tons of little tiny stars being born in there. If you look really closely, you can see lots of little white dots everywhere. So those are stars, and stars are huge. This one here, you've probably seen this picture before. This is the Eagle Nebula, the Pillars of Creation, this part is called. And you can see all of those pink spots are stars that are just being born. And so stars, being huge like they are very, very small compared to the size of these gas and dust clouds. So that's kind of how we think that Mars was formed. That's how we think that all the planets were probably formed. Now we know that the planets are probably not exactly the same as they were when they formed. Because they were formed out of all of this gas and dust that they were scooping up and everything was being pulled together and smushed together, all of that smushing made things really, really hot. And so planets, when they were first born, were probably all molten and liquid, like lava or magma on the outside. They were all just really, really hot and really molten. But eventually they start to cool down. You know, something out in space. Space itself is very, very cold. If you put something hot in the middle of it, it's going to start to cool down from the outside in. And so we get this kind of crust on the outside. And it's still kind of liquid in the center. So we think that that's how, you know, Mercury, Venus, Earth, Mars, these are all of our terrestrial planets, and that's probably how they were formed. And we think that Mars in particular, when it first formed, after a while, probably ended up a lot like Earth. They formed at about the same time. They're made out of about the same kind of stuff. And so we think that they probably had very similar early life. The planets themselves, not life on it, but the planets themselves, their lives were probably very similar. So just like now we have continents and oceans and things here on Earth, we think that Mars probably did too. After that crust all cooled down and it kind of solidified and things settled down and it kind of fell into its groove, we think that it had all of these same features. Now, one of the reasons that we think that is because we can look at how Mars looks now at its elevations, basically, is what you see here on this map. This shows you the areas of Mars where the surface is really high, like the reds and the kind of grayish and yellow colors. And then the blues and greens are where the surface is much lower. Now you can see there's one really big low area that covers the whole northern part of the planet. When we think about areas like this on Earth, places where things are really, really low, that's generally where we find our oceans, right? So we think that maybe all of this low area covering half of the planet might have been a giant ocean. You can also look at it and see, compared to the higher places down in the southern part of the planet, you don't see very many craters, do you? I don't. Or very many other kind of features in this area. So that's another thing that we think that maybe it might have been an ocean that could have washed away any of these craters or other features that might have been there. If there was anything left over from when the planet first formed, if you dump a whole bunch of water on it, it's going to wash away all of that stuff. So these are some of the reasons why we think that Mars might have had a lot of liquid water. It might have had this giant ocean on the top and continents down south, just like we have here on Earth. You also see, you can see the dots there, but we're going to look at them on the planet too. Mars has a ton of volcanoes and mountains, which are pretty cool. Check these guys out. You see those big circles on the planet there? They kind of look like craters, but those are actually volcanoes. Now, they're not erupting anymore. We don't see any eruptions on Mars now, but we can look at the shape of the volcanoes and the size of them and some of the features around them and tell that they were definitely erupting at one point. That one you see right there, that's a very important volcano. It's called Olympus Mons, or Mount Olympus, and it's the biggest volcano in the entire solar system, which is pretty crazy because Mars is not a big planet. It's only about half the size of the Earth. So for it to have the biggest volcano is pretty cool. Now, it's so big that it's 3 times as tall as Mount Everest. And if you set it down here on Earth, it would cover the entire state of Colorado. So that is a big, big mountain. So we see all of these big features. We talked about a lot of liquid water on the surface. These are things that could rapidly change the surface of Mars. You can think of an ocean, it's going to wash away craters and do a lot of damage that way. Volcanoes can cover things in lava. And if you've joined our Mars talks before, you've probably seen that we have lots of evidence for flowing water in the form of rivers and deltas and streams and things like that. So these pictures might be familiar to you if you've been on our show before. But you can look at those and see that Mars probably had things like flowing rivers at one point. It doesn't take a whole lot of imagination to see, a little creek bed there, or a nice pretty river delta, or something like that. And I know if you've seen these pictures before, you may be getting tired of them, and I will let you know that if you go online and Google for the Mars Reconnaissance Orbiter, there are thousands of really amazing pictures, and a lot of them have cool water features like this. So I highly recommend going and checking that out too. But these are some of the most striking examples that we have. And so those are some ways that we could really rapidly change the surface of the planet through things like water and volcanoes, or even wind. Mars has a lot of wind as well. But there's other ways that we can change the surface of a planet that are much slower. Now, one of these is also the reason why we think that Mars lost all of that water. If it had global oceans or big rivers and deltas, it certainly doesn't have them anymore. Do you see anything that looks like water on there now? Not so much. Well, another thing that most planets are born with is a magnetic field. And we talked about how they're hard crust on the outside and molten and liquid on the inside. Well, most planets are born that way, but they do start to cool off, and they cool off from the outside in. Now, all of that liquid in the center, that magma sloshing around, helps generate a magnetic field around a planet, and it can help protect that planet. Here on Earth, our magnetic field is pretty strong, because if you look and see our pictures here, we've got that inner core, which is a kind of solid rocky bit, and then there's mushy stuff on the outside and everything sloshing around, and all of that movement helps create a magnetic field. Now, for smaller planets, they're going to cool off a lot faster than a bigger planet. So Mars, being half the size of Earth, cooled down a lot faster than Earth did. So while Earth still has that magnetic field that's protecting us, Mars doesn't. Now, one of the things that magnetic field protects us from is solar wind. Because our sun, and all stars really, are constantly spewing out all of these charged particles. These little bits are coming and streaming out at the planets. Now, our magnetic field kind of deflects them, so they go over and past us, and we're safe that way. But if you don't have a magnetic field, all these particles are just going to hit the planet. Now, these particles can be really, really energetic. And particles of things like an atmosphere are not very energetic. These are big clumps of like oxygen and CO2. When they get hit by these particles, they can actually knock them off and blow them off into space, which is kind of what you see happening with this picture here. You can see all of those solar particles hitting the atmosphere of Mars and stripping it away. And so that's why we think that Mars lost most of its atmosphere. All the atmosphere we see today is a very, very small bit. It's about 10% of the atmosphere that we have here on Earth. And it's almost completely made up of carbon dioxide. Not good for us, but that's a really heavy element that it was probably harder to knock off. And if you don't have an atmosphere, that means your planet's going to be really, really cold. Atmospheres are one of the things that hold heat in. And if your planet gets really, really cold, it's going to be hard to have liquid water on it. Yeah. Now, we won't go too much into the whole atmosphere thing because we're doing a whole episode on Mars's atmosphere next week. So definitely come back and check that out too, because that's going to be really, really fun. So we look at Mars now, we don't see any global oceans or any flowing water on the surface at all. We do see ice though. Mars has ice at its north and south poles. It has polar ice caps, just like we have here on Earth. Now those are made mostly of water ice, but they also have some carbon dioxide ice, what you may have heard of as dry ice, CO2 ice. Very, very cold. Now, what Perseverance itself is going to do, it's going to Mars to check out some different areas that we think used to have water, because these are really good places for us to land and look for evidence of Mars's history. There's a great picture of Perseverance there. Looks pretty cool. Now, specifically, it's going to land in a place called Jezero Crater. Now, this is a crater that, when we look at it, you see, it's got some of those same sort of river features that kind of comes out of the top, and then it spreads out at the bottom in a nice kind of delta, like we saw earlier. Now, this is a crater that we think used to be full of water. This is why we think that too, because it's got that river and that delta. So it's probably washing water down from somewhere else and spewing it out into this lake. Now, one of the important things about places that used to have water, when we think about places here on Earth, those are usually where we find things like fossils, which is pretty neat. These are also areas where, water is moving across the surface and emptying out, and it dumps sediment. All of the dirt and dust and rocks that are moving with the water as it goes down the river, they end up dumping out into that area, which is what makes that sort of fan shape. But when we look at it sort of a cutout view, this is an example here on Earth. Obviously, there's not just a person standing on Mars. This is on Earth. But you see how it makes those layers. This is a thing we call stratigraphy, which is just a big fancy word for layers. But those different layers tell us a lot about what was happening at the time that they were deposited. There was probably some sort of maybe liquid water that was bringing all this dirt and sediment and stuff down to this area. Maybe it was blown in by the wind, but we can see kind of what color it is, what it's made out of, and find out a lot about the history of that area. Let me see, I have a good question here. I think there would be a lot of good evidence of water near the deltas and more north, right? A lot of times, yes. Actually, the best place to look for these evidences of liquid water is not in the far north, because there actually isn't going to be too much there. We can look there and it just looks very flat. But you want to look kind of on that edge where it's transitioning from the rocky, sort of cratered lowlands into the higher elevations where it's more flat. If you want to look kind of right on that edge, because that's the areas where these rivers are flowing and dumping out into the ocean. If we just look at just the very far north part, it's just going to look pretty flat because it's just the bottom of the ocean. So you want to look on, kind of on the margins there, the sort of greenish areas that you see. Great question, though. Now, in these areas, these sort of margin areas, just like we see that stratigraphy here on Earth, where sediments have been deposited and left, we see these on Mars as well. This is a great picture. So you can see how it's very layered like that. And it's kind of on a slope. So this might have been a place where a river was dumping a lot of dirt into a spot, or it could have been blown there by the wind. These could be sand dunes. But here on Earth, these are a lot of the places that we find fossils, because things, things die and they fall to the bottom of the ocean or the sea or the lake or the river, and they get covered over by that dirt, either by the water, or if the water's gone, the wind will blow some dirt on top of them, and that's how they get compacted into fossils and buried in the ground. So one of the things that Perseverance is doing is looking at places like this, first to take samples of some of this rock and soil and figure out what it's made out of and maybe what's sort of special about it, if anything. But it's also looking for evidence of fossil life. Now, probably not big fossils like dinosaurs or anything like that, or even like big plants, but little microbes, maybe. We do find those here on Earth, little tiny creatures that could be buried in those different layers. So that's one of the big things that Perseverance is doing. I just looked out and see we're running out of time, and I promised you I would leave question time at the end. So let's go ahead and get into that. Do you guys have any more questions that I can answer for you? Go ahead and drop those in the chat, and Raimi will relay them over this way. Drink some water. So here we're rolling around on the planet. You can see here on the planet, like even here at this part, up towards the northern hemisphere, it's much flatter than on the bottom. You don't see a lot of features there. What do we got? Another thing that we can learn too, here's a good one. Do we usually go to places where water might have been, or do we check out other spots too? We check out all of the planet. So water is a really big thing when we're talking about looking for life on a planet, because, you know, here on Earth, pretty much everything that lives needs water to exist. And so if we're looking at other planets, we're going to look for that liquid water too. But I think, Amanda, do we have a little map of where all the different Mars rovers have landed? I feel like we do.
Yes, I also think that we do. Where it is, we'll have to dig around a little bit for it, but hopefully we can find it.
All right. Well, she's looking. Oh, perfect.
It's a little easier than I thought.
Excellent. So yeah, you can see we've landed a couple different things on Mars, and a lot of them have been sort of in that kind of area right along those edges of where it was probably really oceany and very flat. So you can see like Opportunity, Insight, Curiosity, Spirit, they're all kind of right along that edge. We have a Phoenix way up towards the north. And then Viking and Pathfinder were kind of right there in the middle of that oceany area. So because water is so important for life, as far as we know, we really like these watery areas. But some of these are going to be a lot more watery than others. I think probably Spirit and Opportunity might have been the driest areas that we landed in. But since we've really been able to land things on Mars and we're really looking for this life, those have been the most promising places for us to look. Do we have any others? Anybody? Let's see. Will we ever learn everything about Mars? Probably not. Just like we don't know everything about Earth. And we've been studying Earth for a really long time. And you have to remember, Mars is a whole planet. It's not just, you know, it's not a big planet, but it's a whole planet. And if you were just, I mean, our capabilities now, we can take pictures of it from a long way away, or we can land on it and, you know, get lots of really good information of a little tiny area. We still don't have the ability to, you know, do a grand traverse across the whole planet. We haven't like built a big railroad that would take us around the whole thing. So we can learn a whole lot, but we're probably not going to learn everything. So great question, though. I wish we could. I wish we could learn everything about all the planets, but then I wouldn't have a job. So we like to keep our scientists employed too. All right, with that, it is 1:30, so that is all of our time for today. But thank you guys again so much for joining us. Like I said, be sure to come back next week. We're going to have actually 2 guest speakers that are part of the MAVEN mission, which is specifically studying Mars's atmosphere. This is Dr. Laura Petikolas. I hope I pronounced that right. I probably didn't. And the other one is Dr. Robin Ramstad. They both work over at the Laboratory for Atmospheric and Space Physics here in Boulder on the CU campus. Let's see. Oh, we had a couple more questions. Let me see if I can get to these really quick. When are the samples that Perseverance collects on its mission going to be returned to Earth? We don't know for sure yet. It is collecting some samples and it's going to leave them there on Mars for another mission to come back and pick up. So we don't really know when that second mission is going to go to Mars just yet. They're still designing it, so we don't know. But hopefully, fingers crossed, it'll probably be in the next maybe decade or so. That's our goal. We'll see what happens. It's very hard to time these things. So hopefully in the next 10, maybe 15 years, we'll be able to go to Mars and get those samples and bring them back. It's actually a very difficult thing to do. So hopefully that'll be our timetable. And then we've got one more from Carmen here. Was there salt water in the water on Mars when there was water? Probably. We do find sort of salty deposits in the soil on Mars. So there's a good chance that that salt was in the water at some point. Now, we can't really say how salty it was because we can't say for sure how much water there was. But we think that it did probably have some pretty salty water. Maybe similar to our oceans, maybe more or less, but there was salt there for sure. So great questions, you guys. All right, so that'll be our time for today. Thank you so much again. Definitely come back next week to learn more about Mars's atmosphere and more about what happened to it when it lost. Otherwise, thank you to Amanda for flying for us. Thank you to Raby for getting our questions. And thank you guys again. If you have any other questions, drop them in a comment here or shoot us an email. And hopefully we will see you again next week.
All right, bye, guys.
Bye, everybody.